So we'll be seeing a problem for deterministic finite automata. So first problem is design deterministic finite automata to check whether the given string ends in ABA where summation is equal to A comma B. So here we have to check is first thing you need to check is the string should end in ABA. So ends in, we are going to learn the logic for this ends in part. Summation is A comma B. So input is already given A comma B. So logic for this we are going to implement. First logic part means what is the input, what should be the output and how it will work. So all these things, the mathematical model will be defining first for the given problem and then we will go ahead for implementation part. So in the question itself, it is given summation is equal to A comma B, which is the input. Then certain finite set of states we will require Q. So for the time being, we'll keep it as blank. Then we will add depending on the implementation. Then if you see here, delta is their transition function that will come into the implementation part. Q0 is the start state and F is the final state. So we'll come to the implementation part. So it is given transition function delta is Q into summation gives us Q. So this is given. So what does this indicate is Q is the set of states and summation is the input. So this is Q is the set of state and summation is the input. So Q and summation. Q, we are starting from Q0. So start state Q0 given by an arrow. A is the input, B is another input. Then we'll be defining few states. So Q0 on the input A and B. So Q0, it will represent input is A. Q1 represents a state in which we have B. Q2 represents, now we want a combination of A, B, A. So A followed by B. So Q2 represents a state AB. Then Q3 represents a state called as ABA. And once we get ABA, we are into the final state shown by a star or asterisk. So how to go about this particular problem? So Q0 is a state and we get A as the input. So Q0, when we get A as the input, already there is an A present. So when we get A as the input, what we will get is AA. So is there any state representing AA? No. So if you get AA, we'll ignore the first A on the left and consider a single A. So it is represented by Q0. Then AB. Is there any state representing AB? Yes, there is a state representing AB. So we will go to that particular state, which is Q2. Q1 already we have B as the input and A comes in. So Q into summation means the states will be having along with the input. So we need to take care of that. So B is already present and A comes in. So we get a combination BA. So is there any state representing BA? No. So we ignore the left B. We'll consider single A. Is there any state representing single A? Yes. There is a state representing single A, which is Q0. Now there is already a B present and a B comes in with the input. So we'll get BB. Is there any state representing BB? No. So we ignore left B, state representing single B is there, which is Q1. So depending on the problem, we need to take care of the input. So Q0 is representing A, Q1 represents B, Q2 represents AB combination, Q3 represents ABA. So this we have chosen based on the problem. Now we are in Q2 state where AB is already present and A comes in. So it will become ABA. So this is a substring that is present, which is represented by a state called as Q3. So Q2, when we get A, we go to a state called as Q3. Next is AB is already present. B is the input. We get a combination ABB. Is there any state representing this? No. So we'll ignore left A. Then we have BB. Is there any state for BB? No. Then we'll have a single B. Yes, there is a state for single B, which is Q1. So this is how we need to take care. Now next we are in Q3, ABA. ABA is already present and A comes in as the input. So A comes in, what will happen is we are having ABAA. Is there any state representing that? No. Is there any state representing BAA? No. Double A? No. Single A is yes. Q0 is the state representing single A. Then we have ABA. Here we have ABA. Then another B comes in. Is there any state for ABAB? No. For BAB? No. For AB? Yes. There is a state called as Q2 that represents AB. So this is how we construct the transition table. So transition table, it says Q into summation gives us Q. So the states we have to define based on the problem. We have to take the input. Against the input, what is happening? We get the states that we should move into. So this is the transition function. Now the states have been defined. So we can write here Q0 is the start state. We have Q1, Q2 and Q3. Q0 is the start state. So we write Q0 is equal to Q0. In this case, we have chosen Q0 as the start state. Then finite set of final states. Here only we are having one state as final state, which is Q3. So depending on the problem, we have to choose the final state. How many final states, one or more final states may be there. Then based on the transition function, we are supposed to draw the transition diagram. So we'll be drawing the transition diagram based on the transition function. So here we'll be drawing the transition diagram. So here, how to go about this transition diagram? We will be observing the transition table or the transition function. So here we are starting with Q0. This is the start state. So we encircle it and then an arrow pointing that this is the start state. Then from Q0, on getting certain input, that is A, we move to a state, we move to the same state. So we have to show that transition. So Q0 on getting A as the input, we are in the same state. Q0 on getting B as the input, we move to another state called as Q2. So this is on getting B as the input. Q0 on getting A, we stay in the same state Q0. Q0 on getting B, we go to Q2. Then we are having Q1 state. Q1 on getting A here as the input. If you check here, we go to Q0. So we'll have a transition from Q1 to Q0. Q1 on getting B as the input, we stay in the same state. So we are going row wise here. So first we considered Q0, input is A. So we go to Q0 input is A, we go to Q0. So first we show the transition, then Q0 input is B, we go to Q2, we show the second transition. Q1 input is A, we go to Q0. Q1 input is A, we go to Q0. Then Q1 input is B, we stay in the same state. Next, we will go to Q2. So Q2 input is A, we go to Q3. Input is B, we go to Q1. So that is the thing we show in the transition diagram. So we go row wise so that we do not miss any of the transitions. So Q3 is the final state. We have to encircle it twice. So Q2 on getting A as the input, we go to Q3. Q3, Q2 on getting B as the input, we go to Q1. So on getting B as the input, we go to Q1. And then from Q1 on getting, now we are left with the Q3 transition. Q1 on getting A and B, we have already covered. Q3, when we get A as the input, we move to Q0. So Q3 on getting A as the input, we move to Q0. Then Q3 on getting B as the input, we move to Q2. So Q3 on getting B as the input, we move to Q2. So this is the transition diagram. So to check whether the transition diagram and function is correct, we should take an example that will help us in checking whether it is correct or not. So we'll refer the transition diagram and transition function and see one example. So the question is ends in ABA. So we'll start with Q0 state and take an example BABA. So this is ending in ABA. So we should go to the final state. So we'll start with Q0. Q0 on getting B. So if you check our transition diagram, Q0 on getting B, we go to Q2. So we'll go to Q2. So here we'll show it. So Q0 on getting B, we go to Q2. Now we move to the right. We'll have only ABA. Now ABA, Q2 on getting A, we go to Q3. Q3 followed by BA. So this is a continuation. Then Q3 on getting B as the input. So Q3 on getting B, we go back to Q2. So we go back to Q2. Q2 on getting A as the input, we go to Q3. So this we are getting from the transition table or transition diagram. You can refer any of those. And when we land up in Q3, it means that the string is ending in ABA. That indicates that the string is ending in ABA. Clear? So what we have done is, in this particular problem, we started with the logic. That is the input is A comma B. Then set of states. Initially, we are not aware. We can start with Q0. After the transition function, we can write down the states. We know the start state and the final state in this particular case. From the transition function, we draw the transition diagram. And from the transition diagram, we can take an example and verify whether the problem is getting solved or not. So it is accepting string ending in ABA. So this is the right solution for this particular problem. DFA to check whether the given string ends in ABA. So this is one type of problem. We will see the next type.